Hello everyone. Today we are going to learn how to apply De Morgan's laws to determine if two or more logic statements are equivalent. So what are equivalent statements? Logic statements would be considered equivalent if they resolve to the same truth values on their respective truth tables. However, we do not always need to go through the process of constructing truth tables. Depending on how the statements are set up, we can apply De Morgan's laws and arrive at the same conclusion. So here I have pairs of different symbolic statements, and we are going to use De Morgan's laws to determine whether each of those pairs would be considered equivalent or not. Now we're going to start by first stating De Morgan's laws, but before that, let's look at the symbols that are used to represent equivalent statements. There are two of them, and they can be used interchangeably. One of them is three horizontal lines, which is inserted between the two equivalent statements, or we can use this symbol also, which is two horizontal lines and then arrowheads pointing in both directions. All right, so either of these can be used to represent equivalent statements. Okay, so first off, the De Morgan's laws looks like this, right? So we have the first one stating the negation starts with the negation symbol, and then within brackets we have P representing one statement, and then the AND symbol followed by Q, close the brackets, and then the symbol for equivalent statements. And then on the other side, it is equivalent to negation of P or negation of Q. All right, and the second one, the second law states negation of P or Q within brackets is equivalent to the negation of P and the negation of Q. All right, so let's quickly study these two statements. So on the left-hand side, we have the negation of conjunction, all right, P and Q. And that statement, that negation of a conjunction, is equivalent to negation of P or negation of Q, correct? So we don't say any brackets on the statement on the right-hand side. We've taken off the brackets, but like we do in algebra, we've distributed the negation symbol to both the statements, negation of P and negation of Q, and we have inverted the conjunction and made it a disjunction, all right? So the negation of a conjunction results to an equivalent statement, which is the disjunction of negation of P and negation of Q, all right? For the second statement or the second law, it says the negation of P or Q within brackets is equivalent to negation of P and the negation of Q, all right? So all we've done here is that we've taken off the brackets, we've distributed the negation to both the statements, and we have changed the disjunction to a conjunction, or if we had a conjunction to start with, it is changed to a disjunction, all right? And what this means is that if we were to create truth tables for the statement on the left-hand side and another one for the statement on the right-hand side, we would see that they would result in the same truth values. So now we are going to apply the two De Morgan's laws to decide whether this pair of statements given below are equivalent or not. All right, so let's look at the first one. We have two statements given to us. The first one is negation of within brackets P and Q, and then the other statement is negation of P and the negation of Q. All right, so if we look up to the De Morgan's laws above, we have the first statement saying negation of within brackets P and Q, which is the same as what we have here on the statement on the left. However, the De Morgan's law states that that would be equivalent to the negation of P. That's, you have to distribute the negation to both P and Q, take off the brackets, and change the and to an or. Over here, in this particular problem, we see that, yes, the negation has been distributed to P and Q. The brackets have been taken off. However, this and was not changed to an or. Instead, we have an and in the second statement as well. And therefore, these two statements are not equivalent. All right, so the decision is these two statements are not equivalent. If this and the second and would have been an or, yes, then it would have been equivalent. All right, so we will indicate this with this particular symbol, which is these three lines crossed out. This indicates that the two statements are not equivalent. What about the second statement now? So we have here the negation of within brackets P and Q. And then for the second statement, we have negation of P or negation of Q. So yes, we have taken off the brackets in the second statement. We have distributed the negation to both P and Q. And we have changed the and, which was in the first statement, to an or in the second statement. So these two statements are equivalent based on the first of De Morgan's laws. All right, so we can say that these two statements are equivalent, and we can also use the equivalent symbol of three lines to indicate that these two statements are equivalent, not equal, equivalent. Now the third statement is negation of within brackets P or Q. And then for the second statement, we have negation of P and negation of Q. All right. So again, in the second statement, we see that the brackets are no longer there. The negation has been distributed to both the statements, and the disjunction, the or on the left-hand side, was changed to an and on the right-hand side, correct? So that matches with the second of De Morgan's laws, which is not within brackets P or Q. So not, just a second, not within brackets P or Q. That matches with what we have here, is equivalent to not P or, sorry, and not Q. All right, so they have changed the or to an and. They've distributed the negation to both the statements, and we don't have any other brackets here. So these two statements are equivalent. All right, they are equivalent, and use your symbols between the two statements to denote that they are equivalent. Now for the next example, we see that we have the negation of within brackets P or Q. However, for the other statement, yes, we have taken off the brackets, we have distributed the negation to both the statements. However, the or on the right-hand side, on the left-hand side was not changed to an and, correct? Therefore, these two statements are not equivalent. These are not equivalent statements. All right, so again, indicate that with the symbol of three lines crossed out. Okay, so if this or on the right hand side would have been changed to an and, then they would have been equivalent. All right. Now the fourth example is a little bit different from the examples that we've worked before. The first statement given to us is the negation of within brackets negation of P and Q, and the second statement is P or the negation of Q, correct? So this is none of these statements match typically the statements that we saw in De Morgan's law. In De Morgan's law, we had the negation of within brackets P and Q. There was no negation symbol within the brackets, no negation symbols to any of the statements within the brackets. So the way we are going to work through this is we are going to apply De Morgan's law on the first statement all right, and see what we get as its equivalent. And then we are going to compare that statement with the statement given to us on the right hand side, the second statement. All right, so let's go about doing it and working like that, and it'll make more sense, right? So negation of negation is a positive, is an affirmation. All right, let's put it this way. The negation of a negation is an affirmation. It changes it to a positive statement, a true statement, so to speak. So when we negate the negation of P, it's going to be simply P. And again, at this point, we are getting rid of the brackets, all right? And then the and changes to an or, and the negation has to be distributed to the Q, so we are going to have negation of Q. All right, so applying De Morgan's law, we changed the first statement to P, or negation of Q, and we see that this statement, all right, this statement is exactly the same as the second statement given to us, and that confirms that the two statements, negation of P and Q within brackets, are equivalent statements. All right? Now for the final example, we see that both the statements are conditional if-then statements, and we also see that the then part of the statements are the same. It's the if parts, the antecedents, which look different, correct? So what we are going to do is we're going to apply De Morgan's law on the if part of the first statement and see if we can transform it into a statement which is equivalent to the if part of the second statement. All right. So what does De Morgan's law state? It says that not the negation of within brackets P and Q is equivalent to not P or not Q, correct? And that matches, this part of the statement in De Morgan's law matches with what we have in the antecedent of the first statement. So we can write or rewrite this as the negation of within brackets P and Q, correct? And that matches exactly with what we have in the antecedent or the if part of the second statement. Therefore, the conclusion is both the statements are equivalent. Both the statements are equivalent, and we use the symbol for equivalent to denote it. All right?